Good day, class. You are all welcome to the third section of differential calculus. Remember, in the first section, we treated differentiation from first principle. Then, in the second section, we treated techniques of differentiation. And in this third and the last section, we are going to treat types of differentiation. Basically, we have three types of differentiation. We have trigonometric differentiation, we have derivative of logarithmic function, and we have derivative of exponential function. Now let us look at them in brief. Supposing you are given the function y is equal to sine x and you have to differentiate it. Then when you differentiate y with respect to x, say dy dx is equal to, when you differentiate sine function, it will give us cos x. In other words, when you differentiate sine, it will give us cos. Then what of if you are given y is equal to cos x and you have to differentiate cos? When you differentiate, you have the y, the x is equal to minus sine of x. Then the next one is if you are given y is equal to tan x. Remember that tan x is equal to sine x over cos x. And I said it in the second section that if you have fractional algebra, the techniques you are going to use in differentiating it is by the use of quotient rule. You can also use quotient rule here to solve it, but without wasting much of our time, if you differentiate it, you have the y dx is equal to sec square x. In other words, when you differentiate y is equal to tan x, it will give us sec square x. Now let us take a look at cot x. If you have y is equal to cot x, and we know that cot x is the reciprocal of tan x, which is equal to cos x over sine x. If you use quotient rule again to solve this, we are going to get the derivative. Then we have the y, the x. When you differentiate this one, it will give us minus cosec square x. Then the next one here is if you have y is equal to sec x, and we know that sec x is equal to 1 over cos x. This one is also in form of fraction. When you use quotient rule to differentiate this, then we have the y, the x is equal to sec x tan x. If you are now giving y is equal to cosec x, cosec x is same as 1 over sine x. If you use quotient rule again to differentiate this, we have the y, the x is equal to minus cosec x cot x. Now let's take some work example to illustrate this one. For example, if you are given y is equal to cos 3x and you have to differentiate it. Now, to have your dy, the x, what you will do here, you differentiate this 3x. When you differentiate 3x, it will give us 3. Then you write the 3 down. Then you differentiate cos. You know, when you differentiate cos, it will give us minus sine. Then you put the minus here. Then you write the sign here. Then you now write your 3x back. Then let us take a look at another one. Number 2 here. Let us take a look at this one. If you are given y is equal to, say, sine 1 over 3x cubed. To differentiate this, we have the y, the x is equal to, what you do is you differentiate 1 over 3x cubed. You know that when you are differentiating, you bring this one down to multiply whatever is here. This will be equal to 3 times 1 over 3x. Then you subtract 1 from the power, it will be 2. Then you differentiate sine function, it will give us cos, then you rewrite 1 over 3x cubed. Therefore, the y, the x is equal to, this cancel this, we have x squared cos 1 over 3x cubed. Now let us look at another example here. If you are given, say y is equal to tan 5x. Now, when you are to differentiate it, we have the y, the x is equal to, differentiation of 5x is 5. Differentiation of tan is sec square. Then you write the 5x back. Then let us look at another one here. If you are given, say y is equal to sec 6x, then the y, the x is going to be, you differentiate 6x, it will give us 6. When you differentiate sec, it will give us sec, then you write 6x, then tan 6x. Now let us take a look at another one here. If you are given y is equal to cosec 6x, here the y, the x will be equal to, when you differentiate 6x, it will give us 6. When you differentiate cosec, it will give us minus cosec the 6x cot 6x. Now let us take a look at another one here. If you are given y is equal to cot 5x, here the y, the x will be equal to, you differentiate 5x, it will give us 5. When you differentiate cot, it will give us minus cosec square, then 5x. Now we are going to take a look at the next section, next type, which is derivative of logarithmic function. Derivative of logarithmic function. Suppose if you are given y is equal to the natural log of x, that is log x base e, which is written as ln x. How do you differentiate it? Now, what you do here is to find your dy, the x, it will be, you differentiate x. When you differentiate x, it will be 1, then over the function itself, which is x, then log, this base will go up, which is e, then it will be replaced by base e. And we know that any log on its base is equal to 1. That means the derivative of ln x is equal to 1 over x. Again, let us take a look at this one. If you have y is equal to log x on base a, can you see this one is on natural base, but this one is on base a. Base a is any base, it could be base 10. How do we deal with it? It's still the same techniques. Now, when you, then your dy dx will be equal to, you differentiate x, it will be 1 over the function itself, then log, this one will go up, it will be replaced by e. This will be the differentiation of this one. Then let's take a look at some examples. Take for instance, we have this question. You say y is equal to the log of 3x plus 2 base a. Base a. How do we deal with this one? There is a shortcut for this, although I've been showing you the shortcut, but that one is not a problem. Now, to differentiate this one, we have the y, the x is equal to, you will differentiate this one. When you differentiate 3x, it will give us 3. When you differentiate 2, it will be 0. You throw it away, meaning that the differentiation of 3x plus 2 is equal to 3 over the function itself, which is 3x plus 2. Then log, this one will go up, then base e. This will be the differentiation of that function. Now let us take a look at another one, another example here. We have y is equal to the log of 4x minus 1 raised to power 2 base e. Now to differentiate this one, we have the y, the x is equal to, this one, 4x minus 1, everything raised to power 2. We have treated it in the techniques of differentiation, in which we use function of a function to differentiate it. And I also show you the shortcut for doing that. Here we are going to apply the shortcut. Now, what we are going to do here is you differentiate 4x minus 1. When you differentiate 4x minus 1, it will give us 4. Then you bring it out. Then you move this power down to multiply it. Then over the function itself, which is equal to 4x Now, we are given this function y is equal to log 4x minus 1 raised to power 2 base e. How do we differentiate this one? To differentiate this one, we have the y, the x is equal to, now this 4x minus 1 raised to power 2 is a problem using function of a function to differentiate. We have treated this one in section 2. Now, what we are going to do here is we are going to differentiate 4x minus 1, which is 4. We bring it out. Then we use this power to multiply it, which is 2. Then we rewrite the function, which is 4x minus 1. We subtract 1 from the function, which is raised to power 1. Then over the function itself, that is the rule of logarithmic, the differentiation of logarithmic function. Then we have it this way. Then log, this one will go up to be replaced with e. Then we have this log e base e is equal to 1. Then we are now left with, this is 8 multiplied by 4x minus 1 over 4x minus 1 raised to power 2. This will cancel one of this one to remain 1. Therefore, our dy, the x, will be equal to 8 over 4x minus 1. Now, let us take a look at the third section, or the third types, which is exponential function. Let us look at how to differentiate exponential function. Exponential function. Supposing if you are given y is equal to e raised to power x, when you differentiate it, that is the y, the x, it will also give you e raised to power x. It will not change. Now let's take some example to illustrate this. Number 1, if you are given y is equal to exponential 2 raised to power 2x, now to differentiate this one, the y, the x, what you will do is you differentiate this power. Differentiation of 2x is 2, then you bring it down, then you will write this 2e raised to power 2x. That will be the differentiation. Now let's take another example. Number 2, if you have y is equal to exponential minus 2x minus 1, then the y, the x, will be equal to, you differentiate this one. Differentiation of minus 2x is minus 2. Differentiation of minus 1 is 0. You throw it away. Then exponential minus 2x minus 1. Then let's take a look at the third one. We have y is equal to exponential sine of 4x. Then our dy dx will be, now you differentiate sine 4x. You know how to differentiate sine 4x before. That is, you differentiate 4x, it will give us 4. Differentiation of sine, it will give us cos 4x. Then you write exponential sine 4x. Now let's take a look at number 4. If you have y is equal to exponential tan of 5x, what will you do with this? Now, to differentiate this, we say dy, the x, is equal to, differentiation of 5x is 5. Differentiation of tan is sec squared, then 5x exponential tan 5x. Then let us take a look at The fifth one, if you have y is equal to a raised to power 2x. You know, the one we have been teaching is exponent e raised to power something, e raised to power something. But this one is not e, but a raised to power something. The method we are going to use, the approach we are going to use to this will be different from this one. What we do is we take log of both sides. We take log of both sides. Now, when we take log of this, we have log y is equal to the log of a raised to power 2x. Then we have log y is equal to, according to the law of logarithm, this power 2x will come here. We have 2x log a. Now, what next? We differentiate. Now, when we differentiate log y, as usual, when you differentiate y, it will be 1 over the function itself, y. Now, log, okay. Now, let us continue this in the next page. You have log y is equal to 2x log a. Now, what are we going to do here? Now, on which base is base e? Base e. Now, let us differentiate now. When you differentiate log y, as usual, when you differentiate y, it will be 1 over the function itself, y. Now, log e base e will be 1. That one will go away. Or let me just put it, log e base e. Now, because it is y you are differentiating, you put the y, the x. Is equal to, here we have two products, 2x and log a. Now use product rule. You differentiate this one and keep this one constant. You keep this one constant, log a base e. When you differentiate 2x to give us 2. Then plus, now keep 2x constant. Differentiation of log a base e, since you are differentiating with respect to x. When you look at this log a base e, it has no x function. It will be treated as a constant. Then its differentiation will be 0. Then we have 1 over y, log e base e is 1, it will go. Then we have the y, the x is equal to 2 log a base e. Now, we clear this denominator by multiplying both sides by y. We have the y, the x is equal to 2y log a base e. Here, you now replace your y. Therefore, our dy, the x is equal to 2y. What is our y? Our y is a raised to power 2x. Then log a base e. Now, that is what we have for this one. Let's take one more example. That's our question 6. Before we call it a day, y is equal to a cot 5x. This one is also a raised to power. So we take log of both sides as well. So take log of both sides. Then when we take the log of this, we have log y is equal to log of a raised to power cot 5x. Then we have log y is equal to this power cot 5x will come down here. We have log a. Remember, they are all in base e. Now we're now free to differentiate. Now when you differentiate this one, we have 1 over y. We have 1 over y, the y, the x. We eliminate the log e base e part of it. Then it's equal to, now you differentiate this one by keeping this one constant. The differentiation of cot 5x is, you differentiate 5x, it will give us 5. Differentiation of cot, it will give us minus cosec squared, then 5x log a base e. Now plus, keep this one constant, which is cot 5x. Differentiation of log a base e, since it has no x function, it will be 0. Then we have 1 over y, the x is equal to minus 5 cosec square 5x log a base e. Now we multiply both sides by y to clear this denominator. We have the y, the x is equal to minus 5y cosec square 5x log a base e. Then you now replace your y. Therefore, the x is going to be minus 5. What is our y? Our y is a raised to power cot 5x. Then cosec square 5x log a base e. Thank you very much for being patient with us. Make sure you watch the three sections of differential equation. Then very soon I'm going to introduce us to integral calculus as well. Make sure you subscribe and hit on the notification bell for more updates. Thank you very much.